Discuss the problem number of subarrays that match a pattern 1 of weekly counters 384. You are given a zero index integer array nums of size n and a zero index integer array of size m consisting of -1, 0 and 1. So it says that the pattern will only consist of 0, 1 and -1. Uh, let's say a subarray nums of I comma j of size m plus 1. So this has to be noted. Is said to be a match the pattern if the following condition holds for each element of array of k in a pattern of k. Let's simplify these three patterns in a good way. So these are the condition which they have given. So this is in a, this is a +1 state and this is a -1 state. So actually these both refers that these both are adjacent. These both are adjacent elements. Here also I plus k plus 1. This is I plus k. So this is the previous element and this is the next element. So now simplify here. If pattern of k equal to 1, equal to 1 in the sense we have two adjacent elements, right? So this is the +1 state. +1 this state means it is the next element. So it should has to follow this symbol. This symbol in the sense the previous element should be less than the next symbol. What if it is 0? If pattern is 0, then both the elements should has to be equal. Both the elements should has to be equal. This is the +1. And what if it is -1? So -1 the state it has to be greater than the next element. So this is a simplified version of our condition. Let's say compare it with an example. Let's say if we have 1 and 2 and 3 and the pattern is 1 and 1. So if the pattern is 2, then the subarray has to be at least, not at least, it should be exactly of size m plus 1. So this is what they have mentioned in this line. The subarray of size m plus 1 should have m plus 1. Right? So we'll just check upon one by one. See, these two adjacent elements which is correspond to this first element. These two adjacent elements which correspond to this element, right? So now let's ask the question like here k is equal to 1. Can we insert this symbol over here? Can we insert this symbol? Yes, right? 1 is less than 2. Yeah, so this is accepted. Yeah. Then here also we have 1. So for 1, we need to insert this symbol over here. Can we insert that here? Yes, 2 is less than 3, right? So we can insert. So for this, it means that this is a correct subarray like that. So it can be, we can add this to count. We can add this to count like that. So now let's take a big example. Let's say if let's go upon this particular example. We have 1 till 6 and 1 1, right? So we have let's keep that diagram over here. Let's the array will be 1 2 3 4 5 6 till 6 and that matching pattern will be 1 and 1. So for 1 and 1, initially we need to have this all the subarrays of some of size m, right? So we need to initially we'll just check for this particular array, this particular subarray. So can we insert 1 over here? Can we insert 1 over here? Yes, right? So for this case we will add 1. Let's suppose say. So this is getting compared with this particular conditions. So for this we will just suppose to add only my less than symbol, less than symbol and less than symbol. Yes, it's working. So we will just add this particular array 1. Now let's say check the second subarray 2, 3 and 4. Can we check with this particular condition? If k is equal to 1, we need to add this thing. We need to add these things, right? So it will also be okay. Then let's check with the next case. Next case is starting with 3. Starting with 3, we are just comparing with the pattern. So here it has become 3, right, previously. Now it has become 3. Since we have done with this, and we also done with this as well. So at last we have 4, 5 and 6. 4, 5 is increasing and 5, 6 is increasing. So all this pattern will get increased. So at last we will have 4 as a, 4 our answer. So that is why we have got. So what we are initially, this is the first step, like try running. We have 1, 2, 3, and we are checking with 1 and 1. And second iteration we have 2, 3 and 4. We are checking with 1 and 1. In the third case we are checking with 3, 4, 5. 3, 4 and 5. We are checking with 1 and 1. At the last case we are checking with 4, 5 and 6. We are checking with 1 and 1, right? So these are the possible iterations we are performing at each step. So we are checking with this and this, like that. So let's take the second example for now. So it will be a good example. So let's say if you have 1, 1, 1, 4, 4, 1. We have 1, 4, 4, 1. 1, 4, 4, 1. 3, 5, 5, 3. 5, 5, 3. And the pattern will be of 1, 0, 1. So for reference we need to keep this part, right? So we'll just copy this part and place it over here. So this is a problem, and we are supposed to add this thing. So we'll just add in our top. Okay. So for now, mm, mm. So since our k is equal to 1, we need to k is equal to 3. M is equal to 3. The size of the pattern is 3. We need to check for all subarrays of size 4. So this is of 4 and this is of 4, like that. So initially we'll just create a new subarray. Just so for simplicity we'll just creating new 1, 4, 4 and 1. We are just checking with 1, 0, 1. So we need to ask questions like that. So since pattern of k is equal to 1, can we insert this symbol over there? Can we insert this symbol? Yes, right? So this is one point. Are these symbols are same? Since the pattern of k is equal to 0, we need to check whether both are same or not. So here both are same. Both are same. And for 1, -1 the sense we need to insert this kind of symbol. Not insert kind of, we are just supposed to check with the pattern. That's in the case, right? So this is working. Now let's go on to the second thing. So this is working. C and T is equal to 1. Now check with the second subarray. Second subarray in the sense this to this. Now let's take this subarray. Now let's take this subarray, and the subarray in which we have is this is the particular, right, this thing. So this is the thing which we are making. So we have 4 and 4, but we are supposed to check with, we have 1 means we need to check with this particular condition. In this particular condition there should be this symbol should has to satisfy. Is this particular condition satisfying? No. No, right? No. In this 0 in the sense we need to check whether it is same or not. Are these same? No. This is not satisfying. This also no. Here it is -1. -1 in the sense this particular element should has to be bigger than this. This has to be bigger and this has to be smaller, right? So this is also not satisfying. So for simplicity, how we will make these conditions during our coding implementation means we are checking whether the count of OK is equal to M or not, right? So in this first case, we have mentioned all as correct only. Here also we have got okay, okay, and okay. So these three are considered during our evaluation. So if it is equal to 3, then we are just supposed to add. So here we have got a correct answer as 0. Like okay as 0. That's why we are not adding these. So let's take this particular part. Hmm, hmm. Now let's take this particular part. Hmm, hmm. It's taking too much. Hmm, hmm. Now let's take 4 1 4 1 3 4. 4 1 3 5. Here it is 1. It is not satisfying. Here it is 0. It is not satisfying. Here it is minus 1. This is also not satisfying. So we will just neglect this array as well. Now we'll just be think for 1 3 5 5, right? 1 3 5 5. So 1 3 5 5. Is it okay? Okay. 0 in the sense this has to be equal. Is it equal? No. This has to be minus 1. The first element should be bigger, but both are same. This also not satisfied. Have we got the OK as 3? No. No, right? So we are supposed to neglect this array as well. Next, mm, let's take the last one. 3 5 3 5 3 5 5 3. So initially k is equal to 1. We need to insert this symbol. Is this symbol applicable? Yes. Here it is 0. Both should be has to be same. Yes, it is same. Minus 1. Is both the first element should be greater and second element should be smaller. Is it satisfied here? Yes, it is satisfied. So all these three conditions are satisfied over here. So we are just incrementing C and T as 2. So this is how we will just calculate. And one more thing, during our implementation, to simplify the subarray count, I have just checked with these things as well. So I checked with the 553, there is no match, and I checked with 3 as well, there is no match, that's only. I think we need to check for all the subarrays till k plus 1, something kind of. Hmm. Let's move on to this. We'll just delete everything. Hmm. Hmm. Now, let's see. uh, what we need to actually do. First we need to pick up this particular subarray, right? We need to check for this subarray. So we are starting from I is equal to 0. I says that this is the initial stage of its subarray. Current stage the okay, like how many conditions are satisfied during the implementation, like that. So in this case, Mm, we are checking with a pattern of k equal to 1. Equal to 1 in the sense nums of I plus k plus 1 should has to be uh, greater than nums of k. So as per our condition I wrote. So I plus k should has to be greater than I plus k, right? So if it is satisfied, then we'll just increment. So if 0, then both has to be same. If pattern of I is equal to minus 1, then the next element should has to be less. It means that the current should be greater and the next should be lesser. So if we need to simplify this particular problem, then we can simplify this condition and can write as well. So why I have mentioned this statement is I have running till n. So but we don't need to run till n. We need to run, let's say if we have m is equal to 3. M is equal to 3, right? We need to check until 0, 1, 2, 3, 4. We need to check till 4 only. So n has to be less than equal to 4 kind of. Huh. I has to be less than equal to 4 kind of. So instead of 4, how we can write 4? The total number of elements 1, 2, 3, 4, 5, 6, 7, 8. So the total elements will be 8. So 8 minus m is equal to 3. M is equal to 3 is in the sense 5. So we will run till 8 minus 3. So how we can write? So let's check whether this particular condition is working or not. Right? It is working, accepted. So we'll just simplify this condition k minus m. So we have done that particular operation. We'll just check with the sample cases. 4, 4, and we'll try to remove this condition. So we are just checking whether now we are not checking with the out of bound errors, right? Yeah, it is working. Now let's try to submit. It is getting accepted. So the main thing here is how we can modify this particular segment. So initially, if it is being like not understandable, so after making this particular option, we can understand how we can move through. Also, keep in note of current. So current is equal to 0, then we are supposed to add. We can also make similar operations like if anything is wrong, we can break and come out of the loop and etc. But if you are doing like that means then it won't be help in the problem 4. So since this plays a key role in our problem 4 as well, so try to solve in this way. Hope this video is helpful. Thank you.